The last of our revisited topics from part 6 is hypothesis testing. Our same 5 steps apply. First big change, instead of talking about P, we are now talking about mu, the real population mean, instead of the real population proportion. So that's a little different. Just like with P, well, actually, when we did proportions, it was usually easy to spot which was the null value, which was the hypothesized thing that we were testing, because normally we had a P naught, we had an X, we had an N. We didn't have to worry too much about P versus P hat. Where in these particular questions, it's going to be much more common that we have 2 different means or 2 different averages running around, and we need to decide which one is the hypothesized value, the test value, and which one is the evidence, right, for whatever the heck we're trying to prove with our alternative. But just like in the P section, this is all going to come down to, this is always in the same sentence as N sample survey, something telling you that this is from a data set, is not the true value, or is not the value that we are claiming that we're going to test. So if you can spot your X bar, then you know the other mean or other average is going to be the one in our hypotheses. Calculating your test statistic, again, just jumping straight to the formula sheet. Obviously, since we've been using Z interval and T interval, we have Z test and T test in our calculators for a shortcut. And then after we find that test statistic, we can calculate a p-value, a probability. Again, this is going to be about tails, either a right tail, left tail, or 2 tail. But we're going to have a little bit of funkiness going on when we do this by hand for the T test, because our table really isn't set up the right way to use it for a p-value. So I'm going to show you guys that, and that's one of the more important pieces here. So exercise 7.4.1 says that a 2-sided hypothesis test was done with a sample of 20 people, and the test statistic was a t, negative 2.4. What is the corresponding p-value? If we wanted to, one of the first things we could do is draw a picture. Our t distribution is very much like our normal. Remember, it is symmetric, unimodal, bell-shaped, just has fatter tails. And we're looking at negative 2.4. And since it's a 2-tailed test, also care about this, right? So these are the 2 tails. That's the area we want. Now, we know if we're going to do this by hand without the calculator, we're going to need to use that table. So we could use the df n minus 1. Once we have that, we can go, okay, well, our n was 20 minus 1. We need 19 for our degree of freedom. And let's just go glance at that table and see what the hell happens. So if you're feeling clever, I want you to try to think about how the heck you would use this table. We know the degree of freedom is 19. How are you going to use this to figure out our p-value? And what this comes down to is this table is not like our normal table. It doesn't have the probabilities inside of it. It has the t's inside of it. And the probabilities, all the tail probabilities, are up here at the top. So we said we were looking for 2.4, right? I'll just redraw our little picture. We said anywhere between negative 2 or less than negative 2.4 or greater than positive 2.4. So what you actually have to do is go down your little row for 19 until you get to where 2.4 would be. And hopefully we can all agree that 2.4 would be between 2.2 and 2.5. Doesn't matter which one it's closer to, somewhere between those. And that means, so we use that and we go until we find it. And then we go up to the top where all the tail probabilities are. We don't know exactly what the tail probability is for our t distribution that we're looking at, but we know that this probability is somewhere between 1% and 2%. So that's what we're going to take back to the notes. We're going to say, all right, well, our p-value is somewhere between 0.02 and 0.01. Always writing the smaller value first, even though that's the opposite of what you see in the table. Now, that's only this area, right? Since this is a 2-tailed test, we have to do exactly what we did in part 6. We've got to multiply this whole thing by 2. So in reality, our p-value here is 0.02 to 0.04. We don't know exactly what it is, but it's somewhere in that region. Making our statistical decision, all those cutoffs that we might possibly use are on that table, so we're not going to get in any trouble. You can imagine if our alpha for this question, so looking at step 5, if our alpha was 0.05, we don't know what the p-value is, but whatever it is less than that, so we'd reject the null, versus an alpha 0.01. We don't know what our p-value is, but the smallest thing it can be is 0.02, which is bigger than this, so we'd fail to reject the null. So the ranges will still allow you to do all of your work. Now, I can't remember if the little calculator has this, but you could do this exactly if you don't like the table, especially if you don't like getting this range out. There is a t distribution in the calculator. If you go into t, you see there's an inverse t, which you could actually use to find your t stars. There's t PDF, which is as useless as normal PDF. And then there's TCDF, right? So if normal CDF gives us area under the curve for a normal distribution, TCDF does the same thing for the t distribution. Now here's where a stats wizard might be nice to know how we enter these things. But I'm pretty sure that the order, if you cared to know, is the lower than the upper, just like our normal CDF. So we'll try this out. Let's just do the upper tail so it matches what we did in the table. And then I think you have to give it your degree of freedom. We're testing this out together. I don't remember. We'll see if it gets mad at me for this. So this is the initial value, 0.0134, falls right in between these values, and then I would need to multiply this by 2. So my exact value for this will be 0.0268, which is between these two. So again, you have this range, you can get exact values. There are calculators online that you can just type in your t and it'll give you what your p-value is. But yeah, so there's a lot of ways to do this. And of course, if you use t-test, it's going to pop out your t and your p-value. You're not even going to have to think about looking it up. Last step, you're still going to write your conclusion same way we always do. If we reject the null, we have enough evidence. If we fail to reject, there's not enough evidence. And it's always about our HA in words. And just like when we interpreted our confidence intervals, you should not be using the word proportion in a mean question. So just make sure that you know which type of question you're doing so that you use the right language.